Solving right triangles. A lot of this is going to be similar to what you did in geometry, a little bit new. Sine of x equals y, or if you don't like x, we could say theta. Actually, let's say theta, because that's really what we're doing. We're taking the sine of some angle to get some value, usually a ratio of values. Regardless, how do we get theta by itself?
Divide by sine.
No, it's not really a divide. No, you can't do that. Okay? What you can do is you can use what's called the inverse sine. Okay? We move the sine away from theta. Okay, we put it on y. It becomes what is called the inverse sine. That's how you solve for the angle. You don't divide by it. That's definitely not right. That does not equal, big time no, does not equal 1 over the sine of y. That is not the same thing. The inverse sine is not the reciprocal. The reciprocal is equal to cosecant of y. That's what the reciprocal of sine is, the cosecant. That's completely different than the inverse. The inverse is designed to solve for an angle. Okay? The reciprocal of sine is still looking for a ratio of sides. We have others. We have inverse cosine, and inverse tan. Those are the three that you're familiar with, at least you should have seen before in geometry. Inverse cosecant, inverse secant, inverse cotangent do exist, but for what we're doing today, they're not needed, so we're not going to get into those today. All right, we're just going to stick with the three basic inverses. All right, so let's use those to solve some problems. We're going to solve sine of x equal to the square root of 3 over 2 for x between 0 and 360 degrees. A little different than what you did in geometry. In geometry, you use the inverses, usually to solve right triangles, to find the angles that we're missing in right triangles. So your answer was always less than 90. Okay? Obviously, that's not going to be the case here. I'm telling you that we want things between 0 and 360. Let's use what you used in geometry and go ahead and solve for x. We take the sign away from x, and it becomes the inverse sign. We can go ahead and type that into your calculator. Second sine is where you would find that. Okay, second sine, square root of 3 divided by 2. Make sure you're in degree mode, or you're going to get a crazy answer. We're not dealing with radians at this point in time. 60 degrees. Well, that would be your standard answer for a right triangle. We want all answers between 0 and 360, so we have to go to the coordinate plane. It's a little bit of thought here. Sine is equal to a positive number. Okay, it's understood positive. In the unit circle, sine represented what? X or what? Y. So what we're saying here is that sine is positive, so y is positive. Where is y positive in the coordinate planes? 1 and 2. That's where your answers are going to be. The first we've already found, 60 degrees. The second is going to be the same distance away, from the x-axis. So what angle would that be? What's 60 away from 180? 120. So that's your second solution. So 60 and 120. Those are the two angles that would give you the right answer between 0 and 360. Now, we could have just said, give all answers. That would be infinitely many angles. And how would we figure that out? What other angles would satisfy this? All angles that are what with these? Coterminal. All angles that are coterminal with these. Because they all end at the same spot, right? We could go around another time, okay, and come back to here. Okay, whatever 60 more than 360 is going to give me the same finish, the same solution. Okay, and you can confirm your answers if you want. Okay, we're saying that the sine of 60 is the square root of 3 over 2. Okay, let's see here. Sine 60. Okay, we get that decimal. Square root of 3 divided by 2. Same decimal. Sine of 120. Maybe you screwed up and you said, oh, I thought it was quadrant 3. Well, 60 more than 180 would be 240, right? See that negative? Not the same thing. All right? Same decimal, but it's a different solution. So you can always confirm your answers by typing into the calculator. Any questions on that? Want to do one more of those? Okay, sine is really equivalent to y in the unit circle, right? If we go back to the unit circle, the point xy was represented as the cosine of theta, sine of theta. So y is your sine and x is your cosine. So wherever sine is positive, y has to be positive. Let's do a cosine. Let's do a cosine here so you can get that. Solve the cosine of x equals negative square root of 2 over 2 for x between 0 and 360 degrees. All right, so let's do a cosine so we get a little different perspective on what quadrants to use. Let's do that immediately. Let's just look at it right away before we even figure out what the angle is. Cosine is equal to a positive or negative. What do we have here? Negative. Okay. Cosine represents x. So where is x negative in the coordinate plane? I think 2 and 3. This is the x, right? So basically left. If cosine was positive, it would be the right. So my angle is going to be here and here. I don't know how far I am yet. I didn't figure that part out. Okay? We're going to find that out here in a little bit. So we at least know where our answers are going to be. Does that make sense? Sine positive is the top two. Sine negative is the bottom two. Cosine positive is the right two. Cosine negative is the left two. What about tangent? Well, I'll give you a hint. They're all positive in quadrant 1. So positive tangent. Tangent's easy to remember. It's always opposite. So tan is positive in 1 and 3, negative in 2 and 4. Let's figure this one out. Cosine of x equals negative square root of 2 over 2. X equals the inverse cosine of negative square root of 2 over 2. Inverse cosine, negative square root of 2 divided by 2. I'm getting 135, which is this solution. 135 degrees. That's in quadrant 2. Now, how far is 135 away from the x-axis? So it must be 45 away down here to figure out our other solution. So what's 45 more than 180? 225. Those are the two that are between 0 and 360. All coterminals of those would give us the rest of the answers. Like I said, a little different than what you did in geometry, but the same. Geometry gave you the first answer. We want all the answers. Any questions on that? What's that? X. We're solving the equation. Well, you want to know what x value or what angle, right? You take the cosine of to get this ratio. So if I check my answers right now, cosine of 135 should give me negative square root of 2 over 2, or whatever the equivalent to that is. Negative square root of 2 divided by 2. So that's what we're trying to find. The angles that satisfy that. Question? What do you mean congruent? Well, they're the same distance away from the x-axis, yes. Well, 45 is our reference angle. It's 60 away, yes. Sounds like you guys are satisfied with this. I'm moving on then. Otherwise, you wouldn't be talking. Back. Cosine of arcsine of 2/3. What's arcsine? That's just another way to write the inverse sign. I just want to introduce you to that. You might see that. It's popped up, I think, in maybe chem or physics before. I've seen it. Okay. It's just don't go crazy. You see arc, that just means inverse. Okay, not a big deal. Now, what are we trying to find here? We have a combination of trig functions. The outside is a regular trig function. Okay? It's of an inverse. What's the inverse represent? What are we solving for when we take the inverse? An angle. So this really represents some angle theta. So what are we trying to find? The cosine of some theta. And the cosine of an angle is represented by what? Adjacent over hypotenuse, a ratio of sides of a triangle. So our final answer should be some fraction, right? We're not trying to find an angle here. I don't care what theta is. They didn't ask us to find theta. If they want to know what the cosine of theta is, theta being represented by an inverse. Okay? So let's see what we can figure out here. You need to draw a triangle to solve this. The inverse sign tells us things about the triangle. Okay, the inverse sign of 2/3 represents our angle, right? That's what inverse represents, some angle. If we move the inverse sign over, that's the same thing, right? So we know that the sine of theta is equal to 2/3. Well, that's huge, because That turns into a problem we just had on the test. I give you a trig function. I want to know the other one. They're giving us sine. We want to know what cosine is. So sine tells us what? Opposite over hypotenuse. I need to know my adjacent or the x value. X squared plus y squared equals r squared. X squared plus 2 squared equals 3 squared. X squared plus 4 equals 9. X squared equals 5. So x equals the square root of 5. I want to know what the cosine of theta is. What is the cosine of theta? Square root of 5. So can we answer the original problem? Theta being represented by the inverse sine of 2/3? Absolutely. That's what we wanted to answer, right? The cosine of the inverse sine of 2/3. That's equal to the square root of 5 over 3. We can confirm that. We can confirm that answer by typing it in. As we see it, cosine of the inverse sine of 2/3, some decimal, well, we know what that decimal is, square root of 5 over 3. That's what we want. We want the exact values. We want to know what the sides are, what's the ratio of those sides. That you probably haven't seen in geometry. Now, I did a lot more work than you need to here. So I was trying to explain to you where the numbers all came from and why they go where they do. Let's do one more and try to simplify the process. Okay? Are we ready for another one? Some of you are staring. It's going to be the exact same type of problem. Any questions? All right. Switched up the trig functions. Put in a new number. Let's solve this. Let's make this as simple as a process as we can. When the outside trig function is just a regular old trig function, we need to draw a triangle. Now, if it was an inverse, you're done. You just type it in. Because if an inverse is on the outside, all we're trying to do is find an angle, right? So just find the angle and be done. Write it down. But we don't want the angle. We want a ratio of sides, specifically opposite over adjacent, right? Immediately, we draw the triangle. Inverse cosine tells us what sides we have. What sides are represented by cosine? You see what I did there? Comes directly from this inverse here. Adjacent hypotenuse. I need to know what y is. I get square root of 11. What determines our final answer? tangent. What would tangent be based off this triangle? And that's it. See how much simpler that looks? But I wanted to explain where all the numbers came from the first time we went through it. Okay? Because just memorizing and spitting stuff back out, that's nice, but you're not really learning. Okay? You need to understand the process. Why does this go with this, and this turn into this, and everything else? Okay? And again, we can confirm that tan of inverse cosine of 5/6 should be the same as the square root of 11 over 5.
So we only do that because they don't have the.
We have no idea what theta is. We could figure that out.
Yeah.
But here's the problem. It's probably not going to be nice. It's probably going to be a decimal answer that's going to need to be rounded, and we can't use that. If we don't want to round it, because then we won't get the exact answer. We want to know the ratio of the sides. That's what these trig functions represent. Ratio of sides. A ratio. Right? It's almost like, in some cases, tangent, if you think about it, what does tangent represent here? Slope of this line. Right? I know you don't think of that yet. That's a big time concept in calculus. Find the slope of the tangent line. That's why that's where tangent comes from. That's your change in y or your change in x. I know you're like, wow, that's crazy, but that's really it's a ratio, okay? Slope. That's big time. Big concept in calculus. All right. All right. Let's go back to the basics. More or less stuff you did in geometry. Let's solve a couple of triangles. And I think that'll be enough for today. Solve the following triangles. Triangle A. Let's see here. Yep, it's exactly like what you just did. And I'm reviewing what you just learned so we can lead into the new. See if you got it right on the test. Pretty much exactly like what you had on the test. What should we be able to find immediately? I'll give you a hint. B. What's the angle B? Angle B, capital B. It's a 33. 57. 90 minus 33, 57 degrees. Why not? Is this a right triangle?
Yeah.
In that case, then, these two must add up to what? 90. Or, you could take 180 minus 90 minus 33, but what's 180 minus 90? 90. Totally up to you. I don't care which way you do it. You're going to get the same answer. All right, so I have 33. I have this. What else do you want to solve for, A or C? I heard C first. Sorry. I heard C first. What trig function do we use to solve for C? Cosine. So C equals 5.8 over the cosine of 33 degrees. Or 5.8 6.916. I have 33, I have 5.8, I have A. Trig function will solve that. Tan of 33 degrees equals A over 5.8. 5.8 tan of 33 degrees equals A. 5.8 tan 33. 3.767. Just like you did on the test, right? Actually, I think I made it even easier. I think you only had to find one of those sides, right? I don't even think I required you to find both. I think you only had to find one of them. I think that's what we used. I can't remember. All right, part B. Just A and B. This is the last one. Okay, in this case, we do not have an angle. We have two of the sides. We can still find something immediately. Little b. Pythagorean theorem. (23 squared, 529). 45 squared is 2025. So b squared is 1496. You can confirm these. I'm trying to do these in my head. All right. So b equals the square root of 1496, or 2 square roots of 347. 374. Really? 374. All right. That's been confirmed, right? Now, that's actually kind of nice. That's not a rounded answer. We could use that if we needed to. I don't want to use it unless we need to. All right, so let's try not to use B. Let's try to use A and C to find angle A or angle B. Which one? A. Okay, look at what I circled. I got A, and C. What trig function? Sine of A equals 23 over 45. To isolate A, we move the sign over. It becomes the inverse sign. A is what angle? Inverse sine of 23 over 45. Looks like 30.7 degrees. There's two ways to find B. Use what's given. What's that going to be? Yes, we could. But then, isn't that a rounded answer? Yeah. So it should work, but it might be just a little bit off, just enough to throw us off. Maybe 1/10 of a degree. Sure. Sure it matters. We rounded it off, quite a bit. 1/10 of a degree is, we could have went 3 decimal places. All right. What are we going to use here? Let's use what's given. Let's go ahead and use the inverses. Get used to using them. I think you're right. It does work out to be the same. 69.3. Barely. That's close. But it does work out. If you would have subtracted from 90. What if you found for B first? See what I'm saying? If you found for A first, and you rounded your answer to get B, or he found for B and then rounding us to get A, you actually could have two different sets of answers. Right? Depending on how it worked out. Do we have any final questions?